Lesson number 1, we're talking about whole number place value, reading and writing whole numbers, expanded notation, and addition. And to get started, we've got some key vocabulary words that we need to cover that are going to help us be successful in this lesson. And the first one is the Hindu-Arabic system. And the Hindu-Arabic system was developed in the 1st to 4th centuries by mathematicians from India, and it's just made up of 10 different symbols. Well, those 10 different symbols are called digits, and they're 0, 1, 2, 3, all the way to 9. So some simple definitions for our Hindu-Arabic system. Let's go over here and get the pen. Hindu-Arabic system is just we'll call it our number system. We're going to use lots of symbols today. Our number system. And digits, well, digits are our numbers, and they're just 0 through 9. Now go ahead and pause and get this written down in your notes. Key vocabulary for lesson 1. We've got some more key vocabulary. We've got counting numbers and we've got whole numbers. Now, counting numbers, if I was going to count how many students are in the classroom, well, 1, 2, 3, 4, 5, 6, 7. I'll just keep counting. So 1 is our first counting number. Then we have 2, 3, 4, 5, 6, 7, 8, 9, and so on. And we can represent that with brackets, and then 1, 2, 3. We'll go dot, 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 meaning the pattern continues on and on and on. And we've got our counting numbers. Now, an alternative name for counting numbers would be natural numbers. So you might hear that. Means the exact same thing. Now, whole numbers, very similar. And for whole numbers, well, one's a whole number. We could have 1 whole coconut. We could have 2 whole coconuts, but we could also have 0 whole coconuts. I have 0 coconuts at my house right now. So that's the only difference that we have between whole numbers and counting numbers. Is whole numbers will include 0. 0, 1, 2, 3, and dot, dot, dot. The ellipsis, it just means so on and so on. We just continue that pattern. Go ahead and pause again and get this written down in your notes. Now, one thing we need to cover as we get into this lesson is a little review of place value. Now, we know that a number will always start with the ones place value, 1, 2, 3, 4, all the way to 9. Then we have tens, hundreds, thousands, 10,000s, and 100,000s. So if we have number 742, let's say we have that. We've got 700, we'll line it up with 100. 40, we'll line that up with the tens. And 2, we'll line that up with the ones. Let's go ahead and answer a question. First question we have, in the number 46,235, part A says, what is the value of the digit 5? Well, the digit 5 we can see right here. And that digit 5 is our first one. It must be in the 1 spot. One way we could look at that would be to write our number out beneath our box, 46,235. And we can see that the 5, that must be in the ones. Now pretty quickly we can go ahead and we can look at our other numbers. Part B says, what is the value of the digit 2? So if we come up here and we look at the 2, well, the 2, that must be, we've got ones, tens, hundreds. So the 2, the value of the digit 2 must be in the hundreds. What is the value of the digit 4? So if we look at the digit 4, well, 4 is way over here. We've already written out our number below, and we can see the 4 falls in the 10,000s. So the answer, what is the value of the digit 4? Would have to be 10,000s. Notice that's spelled with an A-N-D-S on the end, 10,000s. Whenever we have a number, we can use a place value chart in order to help us figure out the place value of each individual number. Now this is called standard notation or expanded notation. What we want to do is we want to write the following number in standard notation. This is all expanded out. So what this is saying, we have 4 times 10,000. That means we have 4 10,000s or 40,000. So we've got 40,000 plus Then we have 6 times 100. That must mean 6 hundreds, or more easily put, 600. Then we have plus, and our last one is 5 times 1. Well, that just must be 5. So we're going to add those three together. We're going to get 40,000 plus 600 plus 5. Just as you said it, it must be 40,000, 600, 5. We've got our final answer. We can always work with expanded notation like that to put our answer into standard notation, because standard notation is the way that we write numbers so we can read them very quickly and very easily. Now we want to do the opposite. We want to write the number 6,305,126 in expanded notation. So if we think about place value again, we can quickly scroll back to that page with our place value. We've got ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, and 100 billions. Let's go ahead and think about that as we solve our next problem. So what we have is we have 6 million. So if we have 6 million, that must mean it's going to look something like this. 6 times 1 million. And when we get that written out, 6 times 1 million, we've got the first part of our problem solved. 6 times 1 million. Then after that, we're going to add the next number to it. We've got 300,000, so plus 300,000. 3 times 100,000. Then after that we have 0 10,000s. So when we have 0 10,000s, we don't need to say anything because there's 0. Then if we look next, we have 5 thousands. So that's going to be plus 5 times 1,000. You can see why it's called expanded notation, because everything is much bigger. We're saying the individual place values. We've got a 1 next, that's in the 100 spot, so we must have 1 times 100. Then we have a 2 in the 10 spot, so we're going to get plus 2 times 10. And finally we have a 6 in the 1 spot, so we'll get plus 6 times 1. And we're all done. That's all we need to do for this type of problem. Okay, let's use words to write out this number, and the confusing part about this is there's no commas and everything's very close together. So let's go ahead and insert some commas. We're always going to start from the ones to begin with, and we're going to move over 3 at a time to put in our commas. Oh, let's use a different color other than yellow, it's hard to see. So we've got 1 comma, we've got 3 more digits, we've got 2 commas. So if we want to use words to write out this number, we can now see the place value more easily. It must be 51 million. Then we have 723,000. Spelling is important. Make sure you spell it correctly. If you have any questions on spelling, refer back to your place value chart. 723,000. 642. Our final part, 642. So we'll finish it off. When the problem says to use words to write out the number, you have to use words to write out the number if you want to get full credit. 642. 40. There we go. And we're all done. That's all we need to do. Just take your time, think about place value as you work through this problem. Next, use digits to write the number. 51,027,520. So 51 billion. Let's write it out. 51 billion. Well, we know billion is past millions, which is past thousands, which is past hundreds and tens and ones. Then we have 27,000. Oh, you can see we have no millions. So if we have no millions, we've got 0, 0, 0. 27,000. So we have no hundred thousands. We've got 27,520. So we'll finish it off. 520. And we're all done. 51,027,520. Use those commas to help separate the numbers. Okay, let's add. $2.54 plus $5 plus 9 cents. Now you see some different symbols in there. We've got 9 cents. We could have also written 9 cents with the cent symbol. Or we could have written 9 cents as $0, 9 cents with the dollar symbol out front. I like that better because when we add, we always want to make sure we have the same units. So let's line these up vertically. We always want to make sure when we're adding with decimal points that we have the decimal in the same spot when we line it up. So 254. When we write these out, we don't need to put the dollar sign in front. We need to put it in the end though to remember we have money. Plus $5. That's the same as 5.00. And 9 cents. Now you can see the third way that we want to write that out is the way that we want to write it here when we add to make sure that we align everything. Now we can go ahead and solve. If we go ahead and solve, you can see we're going to have, well, we've got $7 and 54 cents plus 9, that must be 63 cents. Now that was a little different perhaps than you've seen before for adding, because I worked from the left side to the right side. I got the right answer, $7.63. If you wanted to work from the right to the left, you would have got 13, carry the 1, 5 plus 1 is 6, and 2 plus 5 is 7, $7.63. Same answer, either way. And that's it. Hopefully you got all that. If you have questions, write them down. We'll work on the lesson practice to begin class tomorrow. Good job, and I will see you soon.